Well, thank you. We'll get started. So thank you everyone again for joining us for another talk from the LatinX series. This series actually is an initiative from LatinX Abroad, an affinity group with the mission of bringing people as a community and empower us to reach our full potential. Following the mission, we decided to create this space where we want to highlight the science that is being done by Latino scientists, have a space where we can discuss several topics and just hear from one another. We find it that it's very important to showcase what our team members from our community are doing, and also to create this space for visibility of potential mentors and foster perhaps research collaborations. Today, especially, I'm very excited about the talk that we will be hearing, as we will be hearing about different paths that scientists can take in the field. So with that, I will pass it over to my colleague Elena for Women Abroad, who will be introducing the speaker. Thank you.
Hi, everyone. I'm really excited to introduce this speaker today because I think they have an impressive career. Dr. Matus is CEO and co-founder of BioBot Analytics, the first company in the world to bring wastewater epidemiology to market. BioBot uses cutting-edge technology to transform sewers into public health observatories, effectively using wastewater data to evaluate and improve the health of communities. Dr. Matus received her PhD from the Department of Biological Engineering at MIT in computational biology, where Dr. Matus specialized in the emerging field of wastewater epidemiology. Dr. Matus is the co-founder of the MIT Underwood Smart Sewers project, leading the vision and funding for an interdisciplinary research project with collaborators from MIT's Department of Urban Studies and Planning. This work led to the creation of BioBot Analytics and set the scientific foundation for BioBot's water intelligence platform, now serving the CDC and communities across all 50 US states. Dr. Matus plans to expand BioBot's venture-backed platform into communities all over the globe. Dr. Matus has been recognized for her leadership and entrepreneurial excellence, through several awards. In 2020, Dr. Matus was named to the CN Trailblazing Women in Chemistry, then made the Newsweek's list of America's 50 greatest disruptors in 2021, and their list of America's 50 enterprising idealists in 2022. Boston Globe named Dr. Matus number 8 on their inaugural 50 Tech Power Players list for 2022. And Time 100 Next recognized Dr. Matus as a 2022 industry innovator. Most recently, Dr. Matus was named a 2023 Henry Crown Fellow within the Aspen Global Leadership Network at the Aspen Institute. So very impressive and very excited to hear this talk. Thank you very much for joining us.
Thank you. Thank you so much, Elena and Ana Maria, for the invitation and for hosting me here. So I'm going to tell you more about my journey of spinning off my PhD research into a startup. As Elena mentioned, I did my PhD with Professor Eric in the Biological Engineering Department at MIT. And during that time, I specialize in the space of wastewater microbiome or wastewater epidemiology. But every journey has a beginning. And for me, that was back in Mexico, where growing up, I loved science. I didn't know that science was a career that I could pursue. I did not know any scientists in my life. I did not know any business people either, only maybe folks who have very small businesses. But the concept of science, the concept of entrepreneurship were not even in my radar, let alone how they combine. That was my beginning, just a love of science, and kind of coming to MIT for my PhD work, joining a microbiome lab and asking questions of, well, if we can understand the health of people, of a person through their poop, what can we learn about the health of a population through their wastewater? And that was really the question that started everything, my PhD work and then the company. very lucky to have worked with Professor Eric Ohm. He's so creative, and he is very supportive of students pursuing their own passion. One of the labs with a lot of diversity in terms of their research agenda. And again, like, you know, he gave me the opportunity to create this line of work, studying wastewater, which up to that moment, we didn't have any wastewater research kind of before I started. And my beginning was actually, I remember when Eric first sort of like floated the idea of what happens if we look at the wastewater microbiome, our collective microbiome at the wastewater. I remember a lot of my colleagues were very skeptical about the idea and just thinking that sounds pretty hard. Imagine of all of the noise present in the wastewater, how can we get like good data out of it? And when I started as a first-year PhD student, I remember the very first project, we said, let's look for flu, for like influenza in the wastewater. Let's collect the samples over the winter season, and then let's see if the data from the wastewater correlates with the clinical data. And that will be our proof point that wastewater data can provide public health information. This was 2013, so 11 years ago. And what I can tell you is that this was a lot of work. The city of Boston was opening one manhole in Back Bay that they chose for us, and I was driving themselves there with another first-year PhD student, Chris Bandoro, here in the picture with me, with a cooler, and just kind of trying to collect a bucket of wastewater out of that manhole. And we put in a lot of work going back to that manhole week after week, whether it was raining, whether it was snowy, we kept going back, and all of that for basically no results. It didn't work. In that entire respiratory season, which covered from September 2013 until April 2014, we were able to detect the flu only a few times and not in the peak of the season. So there was really no rhyme or reason to our results. And, I had to stop for a moment to think about, okay, what am I going to do with my wiser postdocs and elder PhD students telling me, maybe this is a good time for you to switch project because, again, this is a tough one, and, you already kind of demonstrated getting out there and it not really working well. But for me, it was actually a moment to double down. I just was very curious. Well, why didn't it work? And I began to draft all of these questions about it. Maybe the manhole we opened was not the right one. Maybe that manhole represents, half a block, and I was not getting enough people. Does it represent half the city of Boston, the entire city of Boston, one neighborhood, one block, two houses? Like, I have no idea what population was represented by the manhole and therefore by the wastewater. We were going back every Wednesday at 9 a.m. Well, maybe that's not a good time. What if by then most of the working population in this block has left to go to work? And maybe they are the ones staying home, maybe they are just like running showers or like laundry water. Well, of course, I'm not going to be able to see much. So like the location, time of the day, best times of the day to look for this data. What if influenza is not a good target? Now that I think about it, what is influenza doing in wastewater? Influenza is a respiratory virus. Maybe there isn't enough of it in the gut and in the poop. So maybe it was the wrong target. So I think I had all of these questions, and basically that led to the thesis that we need to, if we want to do wastewater testing, it has to be done in a systems level approach. Really thinking about how do we design this surveillance system to really capture data in a way that is actionable and that reflects what's happening in people and not just like other technical artifacts of doing the work. And that was the birth of a research project called Underworlds that ran between the AM Lab and the Sensible City Lab at MIT. I wrote that grant. I got it funded for $4 million, and that kickstarted these 3 years of research where I had the opportunity to work with many researchers across campus, including my co-founder, Nusha Gailey, who had joined Sensible City Lab with a background in architecture and engineering in order to study smart cities, in order to understand new data, new technologies that allow us to make cities more adaptable and more data-driven. So it was like a perfect partnership, and Nusha and I met each other in 2014, and to this day, we're still working together in the company. So it's been a 10-year work relationship, which doesn't happen that often, but that happened for us. The project, again, from the beginning, it had this big vision of doing real-time epidemiology from urban wastewater, really tapping into a data source that is seamless, invisible, equitable, because it really represents everybody in a town, not just those who have access to healthcare. And that can really allow us to almost like leapfrog a lot of the traditional public health surveillance in some geographies. Kuwait was the source of the funding for this grant, and they share with us how in Kuwait, basically there isn't a lot of public health data reporting and analysis that happens. Here in the US, the CDC has already like a bunch of data collection and analysis protocols in place, but there are many countries around the world that don't have that. So wastewater epidemiology could really become almost like the leapfrogging technology that allows us to bring this data nationwide level for a federal government versus needing to do a lot of like regulation as to how the data is managed and reported in the healthcare system, understanding that, again, who goes to the doctor, who gets a prescription, who is covered and by insurance, all of that tends to bias that data by a whole lot. Among some of the technologies that we worked through the grant were developing hardware. Very quickly, we realized that the hardware available for collecting wastewater from manholes was very expensive. And this hardware was designed to collect basically a 24-hour composite sample, which again, that began to make sense for me that it's better to collect a composite sample over, let's say, 1 day than to collect just like a bucket, like a discrete bucket of wastewater. That makes the data way more reliable. And we began to imagine making this hardware programmable and be able to, let's say, oversample during peak hours, like early in the morning or the evening before bedtime, and to actually reduce the amount of sampling that happens, let's say, in the middle of the night, where we're largely just getting dilution rather than new information. So we also played a lot with automating part of the laboratory process. So not just getting the actual wastewater, but also begin to do filtration, concentration, basically like the pre-processing of the wastewater. So it could be as ready for the final detection and analysis in the lab as possible. Of course, everybody had dreams. We actually built in sensors in this hardware over time, which definitely I think is a very exciting vision for how this can continue to advance. But at least for us, we were very interested in making this piece of hardware a collection and processing tool and still bringing the sample back to the lab to be able to use the very advanced, molecular technologies that are high throughput, right? Like sequencing and mass spectrometry, which is not yet really possible to bring all of that power like on the field. So lots of good times, lots of stories. We use a lot of like fishing thread to hang it, because apparently fishing thread is like very resistant. We over time learned how to use magnets as well to secure it in place to avoid drilling in the manhole. Lots of good stories over here. We may have lost more than one robot in a manhole. And then this study for me was, there's a lot of plots here, but at the high level, what this study showed me was what I needed to be convinced that wastewater data isn't noise, that wastewater data actually, that you can do the work in a way where you actually get population health insights, that we aren't just detecting noise in the system, things like that. And as you remember, I mean, my very first study was a big failure. So definitely that first big study was telling me the opposite, that it was noise, and I needed to be convinced. So this study, what we did is to collect one grab sample, so like the bucket of wastewater, every hour through 24 consecutive hours. And we had various objectives with this study. We wanted to understand if there were times of the day that were better for sampling than others. We wanted to understand what's the density of human versus environmental metabolites and bacteria, again, to understand the density of information in the wastewater and how much of it is coming from people versus just how much of it is coming from the sewer, like ecosystem as its own environment. And we wanted to understand just the diversity of targets that we could be looking for. Because if you remember, again, coming out of my first study, influenza just didn't work. And one of the questions was, well, maybe influenza is just not a good biomarker to follow in the wastewater. So we wanted to really understand, well, what options do we have? So as you can see here, what we found was that there were a bunch of chemical biomarkers shown in yellow here, human-associated metabolites that represented the bulk of the signal in wastewater, and that were peaking in the early morning. So the x-axis is time of the day, starting at midnight, ending at 11 p.m. So this early morning peak, we saw a clear peak in human-associated metabolites, but even throughout the day, human-associated metabolites was the bulk of the signal in the wastewater. Thousands of metabolites, out of which we were only able to identify about a few hundred metabolites to understand what they were, like personal care products, hormones, but there were like thousands of metabolites and many more to be understood there. And the minority of the metabolites were actually coming from the environment, like just from the sewer. So that was amazing. It means that most of the chemistry present in the wastewater is coming from people, from our human activity, from using the toilet, sure, but also from cooking, from showering, from the laundry. Basically, every activity we do that involves the water is leaving that footprint in the wastewater, and that's fantastic. And then from a bacteria perspective, similarly, we found that about 40 to 80% of the sample of the bacteria, the OTUs in the sample, were coming from people, and they belong to the groups that we are used to looking at in the microbiome, like firmicutes and Bacteroidetes, versus the other ones were coming from the environment, were largely proteobacteria. So these at the high level show me, and on the bacterial side, these are relative abundances. They are not absolute abundances like with the metabolites. So it was harder to see a peak, but we definitely saw a decrease of the human-associated bacteria during the nighttime. So together, basically, this showed me that, wow, I mean, really, most of the molecular data in wastewater is coming from people. You can see trends even within a day. And I believe that if we do the work right, the data will be screaming at us. There's just so much density of information of what we're looking for that we will be able to make sense out of it. I was still imagining that plot of like comparing influenza against, influenza in the wastewater versus influenza in the clinic side by side, and understanding the relationship between the two of them. But, we had to take a little bit like this detour to just understand at the basic level what wastewater looks like from a molecular perspective. So coming out at the end of the project, Nusha and I believed there's value here. I mean, just imagine one day doing this type of data collection like everywhere. Just imagine everything we can learn about health, about behavior, and how we can keep communities healthy and more resilient in the face of emerging threats. So we decided we should spin off. And I remember at the time, we had a lot of support, but we also had a lot of skepticism that we were ready to spin off a company. It's like, okay, you have some cool research, but you don't have a product here. What are you going to sell? Some microbiome data from the wastewater, and to whom? To like government, right? So why would they pay for that? And how would you do it? How would you scale it? So on and so forth. So it was just such a not a clear black and white decision that actually HBS wrote a case study on the founding of BioBot, and kind of to help students think through just how do they make the decision if they go for it. Because Nusha and I were convinced, so convinced that there was value here, that we could do it, that government would be a customer, that we would have other customers for this data, and that we would figure it out. We were not sure what was the right first product, but we would figure it out. And so, yeah, anyways, if anybody wants a copy of this case study, I can probably share the PDF. It's a cool one. And it's taught now in the entrepreneurship class at HBS, like every year, which is super exciting. So yeah, our technology, as we took it out of MIT, we iterated on the design of the hardware. You can see here a next generation version of the hardware. We developed assays to look at opioids in the wastewater. So things like fentanyl, heroin, different prescription opioids. We also developed our own visualization tool to be able to show the data back to the customer. And we secured our first customer in the town of Cary, North Carolina. So we did a lot of traveling down there. And you can see here some of our pilot results, which basically we provided neighborhood level data on the use of high-risk substances, as well as overdose and treatment options, like naloxone and buprenorphine and methadone. And at the high level, this was the first time that the town had seen any data related to drug use ever. All they knew up to that point was that they were seeing an increase in overdoses year over year, but they didn't know the cause, and they didn't know how to address it. So these data, we brought them, they were able to decrease overdoses by 40% from 2018 to 2019, basically in 1 year. And that was the first drop ever that they saw in overdoses in the town. This is a very strong case study. It's basically, they were able to focus their resources on an intervention for their town. We focused on prescription opioids as those being the very abundant ones everywhere in the town. We focused on a medication take-back program, and then we focused on a messaging campaign. And those three things combined were very convincing, and the town basically was able to give back a ton of opioids that they used to have in their medication cabinets, to give them back and to basically prevent misuse of those prescription opioids that they realized just how dangerous it is to keep them at home. And they were open to that message because they knew what the data was saying. Basically, before our program, the town leadership had always found a lot of resistance to even have a conversation. And the data gave them a moment to engage the public and to make them care for what the data was saying and to make them take action based on that. As you will see, so even back then, we were already getting a lot of interest from the press. And, this was really important to us because a lot of the government agencies that we wanted to work with to bring this data to them, they just had never heard about wastewater testing. They had never heard about this possibility. So it took a lot of evangelizing to make them realize, actually, maybe this could be helpful for me too. We did our first round of fundraising after doing Y Combinator. I remember as a company, we had to fully focus. We were 5 people, so we had to fully focus on this opioid product related to overdoses. Even though our vision was always just so much bigger, we had to really focus because you need to show your investors that, that people really care about what you're building and selling, and you need to focus for that. So we were fully focused on that. And then, of course, we were coming out of the pilot, we were coming out of signing our first customers, we're coming out of fundraising, and then March 2020, COVID-19 happened. And, by this point, we had been working in the space of wastewater for 7 years, right, between MIT and BioBot. So we had seen our first share of emerging pathogens that people get concerned about, but don't really, but are controlled basically pretty quickly. So COVID, when it started, it was one of those moments where we didn't know we should do something about it. But because we were in a startup mode and our potential customers were just busy trying to think about COVID, we got convinced very quickly in February 2020 that we had to build a product for this. So in March 2020, we launched the first ever COVID-19 wastewater test product in the US and in the world, really, which was using data from the Boston area, from MWRA and from the Deer Island wastewater treatment plant. And obviously, since then, we have finally been able to make these plots that I imagined as a first-year PhD student, right, of comparing wastewater data shown in blue here with clinical data shown in gray here. What I didn't know, what I couldn't have predicted at all, was that the wastewater data not only correlates with clinical data, which that's fantastic, but also it is a leading indicator for clinical data. Obviously, I always thought, we should be able to see things quicker in the wastewater because our bodies, as soon as they get sick, will start to tell that story in the wastewater versus if we are waiting for clinical data, that means that people need to self-select. They need to feel sick enough to go to the doctor needs to have a protocol for doing the test and reporting the data out somewhere. But this was just so compelling, and it became a huge tool in the pandemic response, which has been the greatest honor of our lives so far, has been to really be integral to the response to COVID-19. And especially, this data represents the peak for the Omicron variant, which was basically January 2022, and where our data gave a 2 full week leading indicator about, number one, as a huge peak is coming, but also, in about 2 weeks, but also the data was able to show when the peak was going to start going down. So this was incredibly helpful for government officials, for hospitals, for those regular citizens, people all over the US. And this got actually covered in the front page of the New York Times because it was just that critical. The White House was looking at it. Later that year, I testified in front of Congress on the technology. I mean, no, seriously, like just the level of adoption that has happened has been incredible. Wastewater has also, you know, as the clinical data has basically gone away because nobody's taking PCR tests anymore. Wastewater has become the most reliable source of disease prevalence data when it comes to COVID-19, together with new hospital admissions. So those wastewater data and new hospital admissions are sort of like the two officially recognized data sets for the CDC to keep a pulse on what's happening. And that is incredible, right? In just a couple short years, this technology transformed from something that people have never heard about, something that people very obscure, maybe just some experts in academia have used before, to literally being recognized by the top public health authority in the US, in the world, as a reliable source of truth. So incredible accomplishment. And I think this is the largest accomplishment coming out of the pandemic. It's not only, you know, obviously the satisfaction and the accomplishment that our technology and our data was helpful in a deep time of need, but also that it showed there's a very big place for wastewater data going forward. And just to see that sort of like embracing of the technology going forward and seeing the demand continue to grow and grow. Right now with H5N1, for example, there's already so many articles talking about it, papers from academics talking about it, funding from USDA to go talk about it. Actually, I think today the CDC is going to unveil a new dashboard to show the level of influenza A compared this year to last year, to just get a sense of the magnitude of the outbreak in animals, in facilities, and so far. So again, all of that is a testament to the technology delivered, and that to me, it was just definitely filled my heart. It was not easy. We had to do a lot to scale and meet the demand of what was needed of us at the time. Variants, we began to sequence the wastewater as well to be able to capture the evolution of the variants of COVID-19 over time. And this was, again, like a huge evangelizing exercise, because by then people had become used to like the line plots coming out of the PCR data, but to suddenly be open again to a new technology, in this case sequencing data, was a big adaptation. But by now, this type of data is also considered table stakes in the market. Basically, everybody understands you want to look at variants, you sequence the wastewater. And that is, again, a huge accomplishment. This data has been shown to correlate very well with also like the clinical genomic data. So airports has become a new line of growth in the space as well. Here we show some of our data comparing airport wastewater data, which is a leading indicator for what we will see in the wastewater of that region at the community level. So, just this is hinting at, we can think about the growth of the space, not just as the type of assays that we deploy on the wastewater, let's say PCR versus sequencing, or looking for COVID versus flu versus opioids, but also about the type of surveillance or like sentinel sites that we add to a network in order to get the best answers and the best intelligence. So thinking about not just community level wastewater in the form of a treatment plant, in the form of a manhole, but also thinking about transportation hubs, airports, mass congregation sites, specifically vulnerable populations like nursing homes or prisons, right? All of that is, we've actually done work in some college campus and some office buildings as well. So there's a lot of potential as well in thinking about what can different Sentinel sites add to the story and how can we bring value to specific smaller communities as well. Hospitals really use our data a ton to be able to manage their own operation and the use of their facilities during the pandemic. We launched a bunch of other products as well, looking, COVID-19 now. We track various respiratory viruses, not just COVID-19, but different types of influenza and RSV. We scale up monkeypox analysis as well during the outbreak a couple of years ago. And we also launched norovirus, which, by the way, it's unclear that one, how actionable it is from a public health perspective, but from a scientific perspective, kind of fascinating. I don't know what I was expecting, but my thesis was, okay, we only tend to see norovirus outbreaks here and there, right? Like little pockets of outbreaks. So somehow I thought the level, like the background level of norovirus was going to be low. Actually, there's like a ton of norovirus in the wastewater, like all the time. So how is it that we're not all the time just like sick with it? I don't know, but that was kind of fascinating. Just a comment that, again, we scale up monkeypox testing during the outbreak that happened in the summer of 2022, and how we communicated part of the data online, but we did it in a different way, aggregated at the regional level, since this was a much more rare pathogen. So it was just really important to protect the privacy of communities participating in the program, and we decided to report it at the regional level, not even state level. So I think just always having that nimbleness of, what level of information to share with whom and how to analyze it to make it, again, informative and actionable. To me, that's another huge area of growth of the space, is how do we talk about wastewater epidemiology beyond tests, beyond assays, but more about the data and the epidemiology that is teaching us about and how these diseases spread and how these diseases, circulate through our communities, and how do we communicate them to different stakeholders. So that part of science, like data analysis and science communication, I think is like critical, very important to the space, somewhere where we've paid a lot of attention and where we pride ourselves in trying to connect the dots for the different stakeholders. So last few slides, just to mention that we relaunched our drug testing product last year. We expanded it to not cover just opioids, but also other substances that drive overdoses, like meth, cocaine, psilocybin. We believe very strongly that we have a lot of value to add in the space of substance use disorder, because the state-of-the-art data is to look at overdoses, lethal overdoses, non-lethal overdoses. And we believe that, and this actually represents less than 1% of people suffering from substance use disorder. So clearly we have a big iceberg that we can uncover via consumption data coming out of the wastewater, and to really bring programs and interventions more real time and be able to evaluate if, like, the efficacy of different programs when they are deployed in cities and towns, which is a huge issue, that of accountability, and is the program really working? Finally, just to say that we have a code of conduct at the company, and we are the first organization in the industry to publish such a code, basically defining what we stand up for. Why do we do this? To improve the health of communities, we respect privacy, so on and so forth. So we hope that this will inspire a conversation in the space, because as the technology expands beyond COVID-19 into other targets, as it expands beyond wastewater treatment plants into more manholes and buildings, we start encountering a lot of those questions about what should we be testing for or not, and why. And this space is currently unregulated, so asking all of those questions and promoting a conversation is part of what we're doing as well. So with that, I think we're ready to go into Q&A, and just to share, obviously, yeah, I'll be more than happy to answer questions or to elaborate on any of the content covered so far. So thank you.
Yeah, thank you very much, Dr. Matus. That was a great presentation. I myself have lots of questions, so I'm going to open the Q&A to everyone. So please feel free to post your questions. And there's going to be a survey going out in the chat that will give us some feedback. Someone had their hand up. Sorry, I missed it. So in the interim, Daniel Gonzalez. Can we unmute Daniel, please?
I think I am unmuted now.
Okay.
Can you hear me?
Yeah.
Yeah. Hi, Dr. Matus. That was awesome. That was very inspiring. It's a very cool technology, and I think that these sort of very large-scale population approaches are key to, moving forward with, population health and so on. Do you think you would try to move these technology to something beyond, let's say, pathogens or drugs? Like it might be a bit naive to think about like that, but maybe, we could survey overall, nutritional health or, cardiovascular risk, these kind of things that are especially different, let's say, between richer or poor neighborhoods, this kind of like approaches. Are you interested in these sort of questions?
Yes, absolutely. So at the high level, yeah, our North Star is population health, about understanding what's happening in people, basically, just via the wastewater. Indeed, we consider right now infectious diseases and substance use our main two platforms, but we envision going into chronic disease, going into mental health, into diet and nutrition, indeed. We will need to go through some technological developments, right? Because right now, infectious disease and substance use is like a one-to-one. I want to find SARS-CoV-2, I look for SARS-CoV-2 RNA. I want to find fentanyl, I look for the fentanyl molecule. But in order to do some of these other types of population health panels, we are going to have to do maybe more of a on-targeted mass spec, sequencing, all of just different approach to try to discover almost like the fingerprint of those health characteristics. But absolutely, I think that will be, that's almost like the next technology frontier.
Thank you.
Any other? So we have two questions. The first one is from anonymous attendee. What has been the most satisfying and surreal moment from the whole experience, from formulating the idea and being a founder of a company?
So first, I remember the first time that I had literally $10,000 to spend on the company, and that felt like, whoa, scary, So I was a grad student, so even $10,000 felt like such a big amount of money. And then obviously by now our budgets are like in the millions of dollars and things like that. And like that was like a wow moment. Hiring our first employee, who was actually a PhD student who, graduated from MIT and that I worked with. That felt amazing too. Like I couldn't believe it, that this brilliant scientist and woman would accept to come work for us versus pursuing her lifelong dream of going to work at the World Bank. That felt amazing. I think the first time that we realized that just people got it, and that we have, over 12,000 followers in Twitter, and just like regular people caring about wastewater has been like really cool. Just way more satisfying than just like scientists or experts getting it. Just the fact that people at large get it and are inspired by it and they care about it. I feel like that's been amazing. And yeah, I mean, obviously so many moments that, those are good ones. At some point, some of the tough ones, at some point, were basically kicked out of our previous lab space because other tenants were concerned that we were going to infect them by the fact that with COVID, just by the fact that we were looking for COVID in wastewater. So just like the level of fear and like ignorance, that even though we tried to explain over and over again, there was no chance that they could get infected. The mob won, and we actually had to leave that lab space, literally almost like one day to the other. So almost too many. But I think that's part of the journey, like the good and the bad and the very, very bad. But we're still in that. And I think that for me, the day that we start to work with other countries will also be very meaningful, because I consider myself a global citizen and I want to bring this to other parts of the world, not just here.
We have two questions from Javi. When you first embarked on your research on tracking wastewater early in your PhD, did you ever think it would turn into the industry venture it turned into?
No, I didn't. I actually began to think about it as a company only towards the end of my time at MIT. I had tried to start a different startup earlier in my PhD, and it was very different. I mean, yeah, so I was already working on the wastewater as a project. So again, I really didn't think that could be a company. It was a cool project I was very curious about, excited about, but only much later I realized maybe this can be a company, and a big one.
So what skills adjustments did you have to obtain or make transitioning from a PhD student to the CEO of your startup? How did you obtain such skills to learn and make such adjustments?
Yeah, I think that over the course of my PhD, I realized that I really enjoyed, kind of imagining like a vision and like, kind of putting together a project. I feel like I really enjoy that. I really enjoyed like the fundraising side of things, of like, how do I get this funded? Obviously, as a PhD student, it was more like through a grant, not through an investor. I really enjoyed sort of like building a team and like cheering up a team and being like a team leader, and like trying to keep a very nice team around me. I feel like I really enjoy that. Through my PhD, I had already realized I didn't love kind of the writing aspect of science and like, kind of the strong focus on papers. So I think that I already knew some parts of it kind of naturally. It was more exciting for me to be working with people and recruiting people and building a team and things like that than some parts of the science. The learning curve was still pretty tough, especially learning how to talk to investors. There can be a lot of bias against scientists who want to start companies, especially if they are women, especially if they are immigrants, just like the labels begin to accumulate and they just don't trust you with their money. So it took me some time to realize that the investors wanted to hear, I want to make money. I want to be a self-made billionaire. So, I care about the financial outcome, not just about the impact, not just about the science. And I think that was something that, that was like tough just to learn. And then every part of it, learning to hire, learning to fire. But my thinking is that if there are scientists out there who want to start companies, they just need to start doing. Because at the end of the day, in my opinion, being a CEO is like a craft or like a trade. Like you learn it on the job through like practice, through making errors, through talking to other CEOs. There's no school for it. There's no book for it. And like, it doesn't matter if you go to a, HBS or MBA or whatever, like, nothing can prepare you for what it is. So I think I always encourage people to just, if they feel that curiosity, to just go and do and know that it's going to be a tough learning curve, but there's anyways nothing that can prepare you for it. So just get started.
So are you currently hiring? Are you looking to grow your company?
Sorry, I missed that question. Can you repeat it?
Yeah, are you currently hiring? Are you looking to grow your company? Because this is actually going to go on YouTube. So
Okay. Yes, we are. We are hiring for various positions, especially on more like the analysis side, like data science, genomics, bioinformatics. So yeah, and epidemiology as well.
So I had like a couple technical questions actually. So when you said that you took like the whole day's worth of like readings, did you average across the day, and did that provide a more robust measurement, or did you average across certain time points so you can see like what peak times you had?
Great question. So that study, I ran some technical replicates per time point. The best version of the experiment would have been if I had repeated that over like, let's say 3 to 5 days, but it was just so much work. We only did it once. But yeah, I mean, absolutely, you know, we were able to see, we saw suggestions of peak times within the day, and we built our understanding that we need to oversample during the peak times and undersample during the middle of the night. So otherwise, the naive thing to do today is to do a 24-hour composite sample with equal weight across all times of the day. And basically, you end up actually like diluting your sample if you do that. So I think it had very practical implications for us, but we could never actually publish just the peak times and things like that, because we would have had to repeat the experiment a few more times on different days. And it was just too much work.
Did you correlate with like some of the readings you were getting? Like I was looking at the opioids in the geographical plots. Like I could easily see it being of interest to like the police force, right? Because you can actually see what areas have the most drugs being used and see if there's like more access points there for purchase.
Yeah, interestingly, so yes, on our side, we have collaborated with other entities in order to, we actually just published a new study comparing our wastewater data with overdose data available to basically emergency responders. And we found, well, first of all, that wastewater data is a leading indicator for emergency calls. We found out that psilocin, which is an emerging substance that is driving a lot of overdoses, that we can find it in the wastewater before a new case shows up in the ER. You know, we were able to validate a lot of it by comparing our wastewater data with other data. We don't have ourselves access to other data. So when we do that, it's usually through like a controlled study with a partner that has other access and that allows us to learn it, to benchmark that the wastewater data is actually incremental or like complementary to what already exists, which is always kind of an ROI and a value point needed by the customers to procure it. In terms of the law enforcement case, actually, so far, we haven't seen uptake there. Just seems it's not the preference and the policy of many localities these days to take a law enforcement approach to drug use. If it's about drug trafficking, I mean, our data really doesn't really help them get closer to what they want to answer, because really it's about drug use, not drug transactioning our data. So we haven't really seen a lot of uptick there. And for us, it falls kind of a little bit outside of what we want to do as a company too. So it's not like we're trying to validate it for that purpose either.
So we have 2 more questions from Javi. Thanks for your answer to my last question. That was very interesting. Were there any skills that were most valuable that you gained from doing your PhD or being a CEO other than from the research project itself, like the technical skills?
Yeah, I think trouble solving, being scrappy, and flexible to change your mind and to change your approach and to pivot, right? That's a skill that all PhDs need to foster in order to get to the finish line. Resilience to failure, for sure. Working in a team, at least in the lab, science was this like a team sport. So being like a team player, and I would say not being afraid to thinking outside of the box, and to really building disruptive products for the industry has been a huge value add from having the academic background.
And follow-up to that was, or like things you gain from your PhD rather than doing something like working in industry or pursuing an MBA.
Yeah, no, I think that again, I think the creativity of it all, resilience to like failure. I feel like those are just so characteristic of the PhDs that you don't really go through in MBAs. Being close to the technology so you can really put the pieces together. Usually CEOs are the ones who lead product for a very long time before they hire like a product person. And product literally is the combination of like what the technology can do and what the customers want. And you won't believe how many people cannot effectively do it because they are not close enough to the technology. So I think we have that huge advantage, and therefore it's just about how can we learn to bring, to create value for a customer. But we have a lot of advantage having that very intimate knowledge of the technology. That can be a slippery slope where you get lost in the details and you miss the big picture. But if you're very aware of that, then that is a superpower because you can really create products in a very unique way that less technical people can't. And I think also like an MBA, you really don't need an MBA to start a company. I mean, business, you will learn it on the job. And like, at least to date, I just haven't seen like the need for, like an MBA or, I feel like this one, like I know business basically from doing my job.
How did you identify sources of funding initially?
Initially, definitely start like in the university. Usually universities have a lot of programs, pitch competitions. We got almost 100K of non-dilutive funding from MIT programs related to entrepreneurship. Accelerators are kind of the next stage. So Y Combinator or like Techstars, there's a bunch of them. IndieBio. They usually, it's like a good transition to start really connecting with investors. And VC funding is usually like a very clear path for many university startups because you usually need a lot of like upfront investment in order to build your technology and all of that. But more and more, also there's cases where people bootstrap their companies through applying to grants. Every federal agency needs to dedicate 1% of their budget to small business innovation and research grants called SBIRs or SBIRs. So, we at BioBot have had multiple of them, and they are a great source of funding. ARPA-H, NIH, NSF, all of them have very, very good SBIR programs. And that may be a way for you also to get started without needing to go get money from investors. And of course, eventually revenue. You want to start selling as soon as you can, not only as a proof point about your company, but also because that's the best type of money, right? The one that is coming from your customers.
Yes, we're just up here on the hour. I'd like to thank Dr. Mariana Matus once again for this great and interesting talk, and all the best.
Thank you.